thought leadership convention or the trolling community has sent me with my neon cat here. My name is Alvaro, as he well said, and I'm giving the RabbitMQ hands-on or where Shevchenko talk. So about me, I hope the computer doesn't fall. I'm a developer advocate for Cloud Foundry from VMware. It's the cloud platform that VMware has, which also supports RabbitMQ. That's my GitHub blog and my Twitter. You should not follow me, I dare you. You will get like 100 tweets a day for random GIF and whatever, so not much technology there. Yeah, and I created GIF sockets. So if you ever heard of that amazing real-time technology, I'm sorry. I'm from South America, there, that country, Uruguay. Montevideo, yeah. That's me last year when we came with the national team to play, and with Shevchenko there. Anyway, I'm the author of the RabbitMQ in Action book, and I will be giving away this book later, so I don't know how I will randomly choose somebody. Randomly, somebody talked to me before, so. Anyway, so let's start with the talk. It's about messaging and RabbitMQ. I will try to do a live coding session at the end. I don't know how I will manage to get the microphone and code at the same time. At the same time, Ruby, the language, is something I know it exists, so but I don't actually use it. So you can throw the stones now. And this means I will try to code in Clojure. I would have done it in PHP, but that would be even worse. So I will try to do it in Clojure. So let's start. So messaging and RabbitMQ. So what is RabbitMQ? That's a common question. So is it a show server? Can we use it as a queue server, as a load balancer, as an integration platform, as a messaging server? Actually, it's all of it. So usually, at least in the web development community, it's common to say I need a show server, and maybe you think about Gearman or I don't know, something like that, or Amazon SQS or whatever. You like Rescue, I don't know. But because you are thinking about jobs, not Steve, but the stuff you want to do in your application, then it means you are already adding one layer of abstraction to what you actually want to do. You want to send a message from one place to the other, and then that message happens to be a job, like resize image, send email, or whatever. So RabbitMQ is a messaging server, of course, it's a job server, can act as a load balancer, because if you have a queue, you have a load balancer already. Can act as an integration platform, because if you can talk to RabbitMQ from your platform, like from Java or Ruby, PHP, Clojure, or whatever, then you can do integration there. Also, it doesn't matter if you're running Windows, Linux, or Mac, it will also work, and so on. So RabbitMQ is branded as an enterprise messaging system. Wow. So you probably need that. It's an open source project under the Mozilla public license. It's written in L1 OTP, which means it works. And actually, that's pretty cool, because L1 OTP is a language that was made for high concurrency. So if the guy from RabbitMQ doesn't need to write his own concurrency and messaging functions and code, it means less code, then less bugs. And actually, the OTP platform is pretty robust for doing a system like RabbitMQ, or maybe React, CouchDB, and whatnot. Then RabbitMQ, if you need, offers commercial support, and its messaging is done via ANQP. Why I mentioned the commercial support? Because when we started using RabbitMQ at a past company in my previous life in China, I was in China, so there we actually think, okay, there are these options of messaging server. This one has commercial support. Maybe we need it. Maybe we don't care. And I will explain later what is ANQP. And somebody please remind me when I'm about to run out of time. So features. It's supposed to be reliable and high scalable. You should try that. Do not trust my word. can see my t-shirt. Do not trust my words. Anyway, it's easy to install, like RabbitMQ. If you have Erlang running, it's just a matter of uncompressing a tarball and then doing RabbitMQ server start, basically. And we are working on having a one-click install for Rabbit. That means you will, in the future, you will not need to actually install Erlang. I have that working already for the Mac and Linux, but it's not officially supported. So I have a project called Tame Rabbit. You can see it on GitHub. From there, you can install RabbitMQ without the need to install Erlang. As I said, it runs on Windows, Solaris, Linux, and whatnot. It really depends on where you can run Erlang. And it supports those two versions of the NQP protocol, which is basically, if you ask a Russian what Ukrainian sounds like, and the Ukrainian guy what Russian is, so it's the same, but it's not the same. So NQP is kind of have two different versions. I've been having a Russian as a tour guide. So. Anyway, so there are these libraries in Java, .NET, and Erlang. I have those as the main one because they are officially supported by the RabbitMQ team. That means if there is a new feature in the server, those libraries are up to date. Then there are clients for Ruby, Python, PHP, Perl, and whatnot, which probably 80% of those are maintained by Michael Clishin somewhere there. And actually the Ruby NQP gen is by him, also the Closure client that I would be using, and so on. So clap please for Michael. I mean, I don't know how he managed to do so much open source, but anyway. And okay, what is ANQP? ANQP stands for Advanced Messaging Queuing Protocol. It was made for interoperability from the guys like from JP Morgan and so on. They needed a way to lower the cost they have in their messaging servers, like TIBCO and so on. They wanted to have a way to interoperate with their applications without the need to be paying licenses and so on. That's why they created a protocol that also is open and is binary, because from the financial sector they wanted speed, and that means I don't want to open an XML tag and close it every time I want to send a message, like what you do on XMPP. I tried, I mean, once I was an XMPP fan, and it's not fun to be message, blah, blah, all the huge XML, which of course you can write a library that will do that for you. But then, because it's a binary protocol, good luck dividing that on Telnet or whatever. Great. So you cannot use it as simple as Redis, for example, that you just write the commands on Telnet. So this is the only thing I hope you get from the talk. I'm afraid of leaving here on the computer folder. Basically, this is how the message flow works on ANQP. And I don't know if you can read here, but this is actually from Red Hat, because Red Hat has their own implementation of ANQP, and it's, because it's the same protocol, it works also for Rabbit. So basically here, as in any messaging app, you have a producer and a consumer, and in this case, you have a broker. Tomorrow, as far as I understand, there will be a talk about ZeroMQ. ZeroMQ is not a broker messaging, I don't know what. It's a library. In this case, in RabbitMQ, you always have the broker. So there is some daemon running on your servers or whatever. So the producer will send messages to the broker, and what you hopefully will happen, they will arrive to the consumer. Messages go to the exchange. If there are bindings, then they go to queues, and if you are subscribed to a queue, you get the message there. So the exchange works similar like when you have an inbox on your email, and then you have the filters. So you start getting messages there, but then you filter and you find the message on one folder, another folder, and so on. So that's what the exchange is doing basically with the message. It checks some properties of the message, basically the routing key, and we'll see. Do I have a rule for this routing key, a binding? Yes, okay, it goes to some queue. No, By message, adios. So, or paca, whatever. Anyway, so you need to be careful, because if you don't have a binding, then the message is gone. You can publish the message saying that it has to be some properties in the message, like if there is no queue, I want to get the message back, so I'm notified that this message will be sent to discarded, and so on. I mean, if you think in real life, if you write whatever address that doesn't exist in your envelope, then the guy at the post office won't know what to do with your letter, like Videla Skaya, it won't drive anywhere in Moscow, for example. And then you have one or more queues bound to that exchange. Of course, RabbitMQ is optimized to not copy the message everywhere. There will be a reference for that message, so you don't waste memory and disk space. And the message will stay here. If you have a consumer, the message will go to the consumer. If you have more than one consumer, then they will compete for the messages. That's one of the most basic patterns you have in messaging. It's called competing consumers. So you have the queue of messages, and then the server starts to run roving messages around. If a consumer crashes, then the message can be sent back to the server, so it's not lost, and so on. There are way too many options to what you can do, but basically, producer, consumer, broker, exchanges, you send messages to exchanges, you never send messages to queues. That's very important. And you get the messages out of the queues via subscription with consumers. So if you don't have any consumer, you can still have a queue there where the message will be piling up. And again, according to the bindings, you can have many queues getting the message. So, in the MQP model, you have exchanges, queues, bindings, and rules. And actually, you have many kinds of exchanges. This means there are routing algorithms, like the fan-out exchange will do the same like what happened in Twitter. You send a tweet and it goes to all your followers. This is basically what a fan-out exchange does. Subscribe you, the queues will be subscribed there, and then all the queues subscribe to the exchange or bound to the exchange get the message. Indirect is mostly like when you do one-to-one chat, similar pattern. And the topic exchange, you have routing keys, and depending on the routing key is what happens. So where you can use a topic exchange, for example, if you have many servers in production, then you have many applications running there, and various log messages like error, info, warning, and so on. So you can send a routing key saying server1.myapp.info, server2.secondapp.error, and whatever. And then when you bind the queues, you use the topic as what you want to listen about. And then you can really see in real time information about your servers, monitor applications, see even if a new feature that you just deployed works or somebody's using it. You just log in there and you can see that in real time. So that's the fan-out exchange. You get one message, it goes to all the queues bound to the exchange. The direct exchange actually uses a routing key. So if the routing key matches, then the message goes to that queue. The routing key can be blank. So when you do the binding here, you also use a blank routing key or binding key, and then the message will arrive. So you don't need to always specify a routing key. It's good to do it, doesn't matter, but it will be checked or matched against when you send a message. And then yes, this is the topic exchange. For me, one of the coolest things on earth ever. No, but you have like USA.news, USA.weather, Europe news, and Europe weather, and from there you can have many queues. One is interested on everything that happened in the States, another everything that is news, and so on. Because you have fire and forget and this kind of messaging architecture, you can start without changing your code. Basically, you can add a new producer sending stuff from Russia or from Ukraine or from Uruguay or I don't know where. And for example, the one that has hash.news, that will get all the news from Ukraine. and so on. At the same time, if you don't care anymore about what happened in the States, you just kill that red queue there that you say .hash, and then you don't get any more messages about that, even though they can be still published into your server. And then you can realize that no, it was not such a good idea to kill that consumer. You can pull it back and then keep knowing what happens in the States. So let's go to the examples. I don't know if somebody can help me with the microphone. The examples are based on the Clojure library, which comes from the Clojure works. This is a group of people in which Michael is there as well, plus a guy from Ukraine, Alexander Petrov, and they together working in Clojure works, doing many libraries on Clojure, and the one I'm going to use is from them. So I hope you can read that. And let's go here first. Whoa. Can somebody help me with the microphone, please? Thanks. So I will try to run the server, which I think is not running right now. No? Oh yeah, it is. So Rabbit has this is I just unpacked this from a tar file, and basically here you have all the code from the server. So you have the ebin folder, it's the L1 compile stuff, etc configuration, include files, plugins, and so on. Inside sbin, you have the commands that you will use to start and stop the server. For example, ctl status, we can see that Rabbit is running. If we go to the browser, let me see if this is running. Come on, localhost. Maybe it's not running. So, Rabbit, never do a live demo in a conference. Oops. Please. Yeah, I will try to enable now the management plugin. RabbitMQ has a very cool management UI on the browser. So let me see if this works. And Rabbit. I will try to enable the plugin. It worked, so I need to restart the server. By the way, do you have any question regarding what I explained before, or trying to explain about MQP, Rabbit, and so on? So there, I'm trying to start the server again. It's activating the plugins, and now it activates this one particularly. So yeah, that's the management console from Rabbit. You can see that the server is running, that I'm running in a very configuration by default. So I only can have 256 file descriptors thanks to the Mac defaults, and so on. So it's a high concurrent installation I have here. And yeah, that the MQP port is 5672 and so on. I can list connections, channels, exchanges, queues, and whatnot. There are some exchanges that are by default there, as you can see. Then Rabbit has the concept of virtual host. This means you can separate your apps by virtual host, and in similar way that what you do with Apache. It's not the same, but you have users, they belong to a virtual host. Those users can have a read, write, and edit access to queues and exchanges and so on. So there is a concept of administrator user and so on. So let's try to go back here. So this is Clojure code. Tomorrow Michael will do an introduction about Clojure. I don't know how many of you know Clojure. It's basically a Lisp that runs on the JVM. Probably a Lisper will kill me, but let's go with that. So what I'm trying to do, because it's on the JVM, you can import Java libraries. In this case, I will try to import. If I start the console, I think it's a bit better. I will try to import the connection class and the exception class. Emacs with one hand, that works all the time. That's good. So, okay, I imported that, then I will require all the libraries from Langor. Langor, sorry, is the closure works library I told you before, from there. And yeah, it's very nice because it's all separated in all its tiny namespace. So basically, in RabbitMQ you always have a connection, a channel, and then on the channel you do your operations. On the server, you mostly never do anything besides starting the server. You don't create queues doing commands on the server, you don't create exchanges and so on. You should start the server. So, as you can see there, we have a namespace for channel exchanges, queues, and so on, which I will require and will give an alias, so I don't need to type all that in closure. I hope this works. Seems like. And now I will create a connection for Rabbit. So this will use all the default parameters. So the user in RabbitMQ by default is guest. That's the password as well. The default virtual host is the /, and then the port is 555.672. By the way, do you have a number from 1 to 20?
19.
19, okay. And from 1 to 10, somebody?
7.
7.
42.
Yes, so who is on row 7, seat 19? Somebody can give whoever that is this book. Let's continue. So, okay, so let's connect and let's see if this connects. So, I created the connection variable there. Let's see. Yeah, now I have a connection on Rabbit. So, I just did, let's define this variable here as the connection type with default parameters. And now I will try to open a channel. So let's try again. So I create a channel, and with that channel I will start to create the exchanges I will use for this example. So in this case, I will have an exchange called Ruby Shift logs. It will be type topic. It will be durable. This means if the server restarts, it will still be there. And it's auto-delete false. This means if I close the connection, don't delete the exchange. So in RabbitMQ, you have concept of durability, of auto-deletion, and persistence. So when you create a queue, for example, you can create a queue as non-durable. That means if the server restarts, the queue is gone. But you can say it's not auto-delete. This means if this connection closes, the queue will still be there as long as the server is there. That doesn't mean your message will persist. Your message will only persist if you publish the message as persistent. Why so many options? Because you can have a server that is writing to disk for every message that it receives, or will keep them in memory and try to send them out from there. Of course, if RabbitMQ feels that it's running out of memory, it will try to write the messages to disk. So let's try to declare this exchange. So as you can see, I don't know if you can see down here, most of the commands in RabbitMQ always return you the same name, like declare OK. So in this case, we got that the exchange was declared. And you can really check what happened there in qdeclare and so on. If we go here, we should have a new exchange. Here is the one I just created, and it's the type topic, which of course you can see more about it. You can go inside the exchange. You can see that there are no bindings, so this exchange is not bound to any queue, and so on and so on. So, what do we have here? Simple handler to display message routing. Okay. So what I will try now is to create a consumer and then send messages there and see if we get the messages. And because it's a topic exchange, I want to show you the routing key thing. So this handler, whenever you get a message from RabbitMQ, you usually have the channel on which the message came, the message properties and the delivery properties, and the payload, the actual content of the message. So a message in AMQP has the content and the envelope, and in the envelope you have like a reply to property. For example, like when you send a letter, you may write there where to reply, for example, or a correlation ID. If you have many messages that belong to the same operation, you can have a correlation ID and then track what's going on in your messaging app and so on. So this one particularly will print the routing key. I don't want to print the meta information, so let me. Lesson number 2, never edit code in a talk. So, yeah, it will try to print the routing key once we get the message. So now we want to start a consumer. So to start a consumer, of course, I need a channel. I need an exchange because I want to bind the queue of the consumer to some exchange, and the topic is basically the routing key. So this is something pretty cool that you can do with the declare method for queues. When you declare a queue, you can pass the queue name, if it's durable, many options. But if you don't pass any option, RabbitMQ will assign a random name to your queue, will make it auto-delete and non-durable. In this case, I want to listen for logs. So if I want to just cook in a server and see, okay, is this server doing something, throwing errors and whatnot, and then kill the consumer, I probably don't want to be thinking about what's the name of the queue, taking care of deleting the queue afterwards. So the server will do all the cleanup for me. In a different application, maybe you want to have a durable queue, you want to provide a name, and so on. So you can do it similarly as what I did here. You will say, okay, that's the name of the queue, then it will be durable, and so on. So, okay, the server gives a random name. How do I get the name? The clear method for queues returns the name of the queue that you just created. So here in Closure, I'm getting the queue name, and I'm binding that name to the queue name var, so to speak. Then we have a new Java thread where we launch the subscribe method, so the consumer, which means, okay, subscribe to this queue name using this message handler. The message handler is the previous function I showed. Auto-act true means as soon as you get a message, delete it from the server. So RabbitMQ can be tracking which consumer has which message if you say that you will acknowledge the message yourself as a consumer. But if you say auto-act true, you are telling the server, I want to acknowledge any message, so as long as you get it, throw it away. And this RabbitMQ can do a lot of speed optimizations if you set that in that particular way. Depending again what your application needs. In this case, we just want to see logs, so they can be discarded. And then once we get the queue, we do the binding and say bind this queue to this exchange using this topic as the routing key, and we start the consumer. So in this case, now I want to start a consumer on the exchange I just created, Ruby shift logs, and here I have the pattern. So I want to create listen to messages from server 1, and the hash means whatever else, I don't care. It's similar to the star to the dot star in a regular expression. So there we have a new consumer for the queue blah blah blah, really nice name, and the routing key is server 1. So we can see here, okay, now this is auto-updated, and we have that this exchange has one binding. So let's publish a message. So I will send a message to the exchange again. As I said before, you send messages to exchanges. You provide a routing key. So in this case, it's an event that happened in your server 1, application 1, and it was an error. And this is the event. And for example, in the properties, you can specify a content type. If you have a serializer, and this serializer, you can check on the content type and dispatch there, something you want to do. So let's send. So the consumer receives a message from server 1, app 1, error. All good? So now, what do you think will happen if I send a message with the routing key server1.app2.info? Do you think this message will arrive to the consumer or it will be discarded? Exactly. So, let's try. Yeah, there. Good. But now, I have server2 app1.info. In this case, it should not arrive. Please. God help me, as also Osmond used to think. No, nothing happened. Perfect. So let's start a new consumer. In this case, I want a new consumer, but you can see there is a star somewhere here. So this means I don't care what's the server name. I do care what is the application name and the severity of the log. So let's start a new consumer. We have a new consumer there, new queue. We should have a new queue here as well on the exchange. And now let's try to send this message.
Yeah. You start with consumer with user profile.info.
On second listener. It's not user profile, but
Yes! Actually, I knew of that. I was just trying to see if you were paying attention. Please tell me a teacher told you that once. Okay? Yeah, sorry. Yeah. Thanks. You saved my head. Anyway. Yeah, so I started a consumer wanting to be from the user profile application. So why on earth this is going to be a root? Perfect. Thanks. So let's put the user profile there. Emacs, one hand. Never do that. User profile. Exactly. So yeah, now we have the server 2, we don't care, user profile, we do care, info, we do care. Let's see if it works. Yeah, thanks. And you get the point?
yeah.
So this is just one example of what you could do with the topic exchange. Just by sending logs from your app, you can create a publish function that takes the host name, the application name, plus the severity, and that's it. And as you can see, or you could see, thanks to my mistakes, is that we have the queues there that are on the server, and none of them have pending messages, because the messages that were sent with a routing key that was not bound to any queue were just discarded. So we don't accumulate trash on the server, basically. So, any questions up to here?
No.
Why
did you use asterisk instead of dash?
Okay, so the asterisk or star matches per word. The words are separated by the dot, and yeah, basically you have a star dot. You could have a star here also. For example, you can start a consumer like this, or you can have the app name here and the start dot.
It's for first field.
So it's field per field, yes. And the hash matches till the end, basically. Something like that. Okay, this is silly, but I mean, the server name there, but high, whatever. So, how I'm in time? Or 3 minutes? Good. So, of course, I won't show you the example, but as a consumer, you are not only getting messages. Of course, you can reply with new messages. So, for example, I have an RPC handler here that it gets a message. When I publish the message, I add the reply to property to the message. I get that out of the message metadata, and I will reply to the anonymous exchange. There is an exchange on RabbitMQ by default that has no name. Every queue on AMQP is always bound to that exchange by the name. That's the routing key. That means if I publish a message to the unnamed exchange using the queue name as routing key, the message will go to that queue. So when you implement our RPC server, you create your own consumer, you get the queue name of that consumer, and when you send messages, you add that to the reply to property of the message. Then on the RPC server, you get that reply to a string, whatever that is, and you use that as the routing key when sending messages. In that way, your server is not tied to one particular client or exchange. So you could have an exchange name here, but then this server will only reply to that exchange. If you reply to the anonymous exchange using this routing key trick, is how you get the RPC going. So in the client, I do the queue declare again, I get the queue name, and then I do the subscription. And then when you send a message, you can see I have an example queue name there, which of course you will have in a variable. You don't need to remember or type all the stuff. So that's basically how it works. Of course, also you don't need to have only one consumer. You can have many consumers per queue. Then they will compete for messages, and so on and so on. So to do a small roundup. So why RabbitMQ? Why will you care? If you need to scale your app, and if you need to scale whether because you need to add more capacity, you need to remove workers, that's the easiest way to see how you will use RabbitMQ. But maybe you need to scale the requirements of your application. Let's say you have an image upload form, and you're just uploading the picture, and that's it. But if instead every time you get the new upload, of course you store the picture on the file system, wherever you do that, and then you send a message. New image from this user, the image is here, and this is the ID of the image on the laptop, whatever. So tomorrow your product owner comes to you and says, I would like to resize the images. So you just create a resize consumer, bind it to that exchange where the events are being sent, and you got your resizer without even needing to redeploy your original app. Then they tell you, okay, well, I would like that every message that gets here is also sent to Twitter, because we want to spam the friends of this guy. So you can do that, adding a new consumer that picks up that message, and so on and so on. So in that way, you can easily scale to the new requirements of your app without mostly not touching the code. And at the same time, you can remove features very cheaply, basically. So it's more than just saying I need to process this amount of emails and then I fire 200 workers. You could do that. You could do that across the network and so on. It's very easy and one of the most common use cases. But also think about the scaling to requirements and to be able to deploy your apps faster. Then you can interoperate. I didn't show that here, but all these messages that are being sent from Clojure, if you have the client in PHP, Ruby, or whatnot, you can use it there, and also it doesn't matter which platform you're in. Then you have like low operation cost, because Rabbit, you started and then you don't do anything else. Of course, you need to keep track that the server is still there, but that's pretty much it. Then on my previous Mac, which was from 2009, I guess, or 2010, I could do with PHP, which is a very slow language when you are doing AMQP processing on on PHP, not in C. I could do 4,000 messages per second. In Java, in that machine, I could do easily 12,000 messages per second, around 1 kilobyte messages in one server. So you can really scale out pretty easily. And yeah, I don't know if you have any questions. Else, thank you very much. And who is the guy?
Buffer flow. Actually, there was a funding guy, so it's buffer overflow.
Buffer overflow. Wow. We don't have a
19.
type language here. Who wants to go? Who was the guy that was shouting here, the user? Okay. Thanks.